Okay, so this was very similar to example D in the original, in the you try it number 1, where we're given the volume of 451 milliliters, which is 0.451 liters. We're given the molarity of 3.2, and we're left to solve for the moles. Hopefully I don't switch my numbers around again. 1.44. Moles. We get 1.44 moles of HBr, hydrobromic acid. So that translates to how many moles of hydrogen? 1.44 moles of the hydrogen ion. All right, don't get too confident because the first section is always really, really easy. And we're going to work a lot with the section where it says 4.2 and 4.3. Because this is where you will need to become very proficient in knowing the solubility rules. We always have to review them as we come to them each year typically. And you have to be good at writing reactions, writing compounds, that kind of thing. So we'll kind of sit on 4.2 and 4.3 for a bit. I just have one example, and then the you try it will be yours to work on the remainder of the time. So we're at 4.2, 4.3. If you didn't get that or the solubility rule sheet, you'll need to come pick that up. Okay, the first example says, predict whether a reaction occurs when each of the following pairs of solutions are mixed. If a reaction does occur, write balanced molecular, total ionic, and net ionic equations, and identify the spectator ions. So this is essentially taking double replacement reactions, which we learned how to write last year. This is kind of like the next step for that. Okay, I just had the you try it. Hopefully I have the example. Oh, there it is. Okay. So in A, the first thing you're going to need to do is translate the two reactants that you've been given into chemical formulas. So sodium sulfate and Na2SO4, and that is aqueous. And strontium nitrate. I got to check the charge on strontium, positive 2. Okay. And also aqueous. So this is like if we're in the lab and I give you 2 dropper bottles, and one of them has sodium sulfate solution in it, and the other has strontium nitrate solution in it, and you mix the 2 things together. Before you even do the reaction, you should be able to tell, using the solubility rules, whether or not you're going to get a precipitate when you mix the 2 together, which means it's going to look cloudy because a precipitate is a solid that forms out of the solution. And that's the lab that you're going to do Friday. You're going to mix stuff together and see if you get a precipitate or not, and make sure that matches up with solubility rules. Okay, so let's look at the 2. First, you have to kind of consider what 2 products will be formed or could possibly form in this reaction. So again, this is review of double replacement from last year. So what happens is the sodium, the positive ion from one compound, hooks up with the negative ion from the other. Now, don't forget that you have to take into consideration the original charge or the actual charge on the ion. One of the most common mistakes is to just kind of carry these subscripts over with it. These are only there, remember, because of the charge on the other ion that it's with. So I suggested when I taught this last year that you make a note when you have to predict the products. You just sort of make some notes as to what the original charges were on each ion, or what the actual charge is. And you can make those notes anywhere, but I always just, modeled making them over the top. That way, when I'm saying, okay, I got to put a sodium with a nitrate, I can see that sodium is positive 1 and nitrate is negative 1, and so I know those charges just are going to cancel out, and my first potential product is NaNO3. State to be, aqueous or solid to be determined later by using my solubility rules. Okay. The other piece is strontium and sulfate, positive 2 and negative 2. So those also cancel. don't forget to write the strontium first in the compound. That's the other common mistake that I see. You go, okay, these two go together, and you copy them down in the same order that they appear here. Make sure you're always writing your positive ion first. And those are just kind of basic things that I see tripping people up occasionally. So now I have to figure out if either of these will be a precipitate or won't stay dissolved in the solution as ions. So I'm just going to take them a piece at a time. So I need to find something about sodium or alkali metals or something like that, or something about nitrates in my rules. So let's look at rule number 1. All salts of the alkali metals are soluble. So what does that say about sodium nitrate?
It's soluble.
It's soluble. Yes.
You need to balance the
It probably isn't a bad habit to get into. With this particular activity, it's not as important, but let's go ahead and do it. That takes care of it. Because it will become important.
I have a question.
Yes.
How do you know it's salt?
It is neither acid nor base.
How did you know that?
What would an acid look like? What would I recognize that
It
an
has
acid?
hydrogen.
Oh, right, it would start with a hydrogen there. And then a base would be a hydroxide or ammonia.
So everything else is salts?
Think of it this way. If I could put a hydrogen here and make this an acid, then this is now a salt. All right. So this is soluble, so that means AQ. That means those ions exist in the solution just as ions. They've busted apart and they're staying that way. Okay, so I don't even have to know anything. There's probably a rule about nitrates there, but it's irrelevant. If I've got an alkali metal, I'm done. That's soluble. So knowing that one rule helps me there. So I'm stuck on this one. Okay, so I need something about strontium or alkaline earth metals or something about sulfates. So I keep going. Rule number 2 says all ammonium salts are soluble. I don't have ammonium. Number 3, all salts containing the anions nitrate, chlorate, perchlorate, and acetate are soluble. That doesn't apply here. I look at 4 and it says it doesn't apply. 5, I've got sulfates, so I think I'm on to something here with number 5. All sulfates are soluble except, it tells me lead, strontium, and barium. So I have an exception here. Okay, so all sulfates are soluble, but not this one. So that means it's a precipitate, which means it's going to come out of solution as a solid. So this reaction does occur. I'm going to see something happen when I put them together. I don't just put 2 clear liquids together and see a clear liquid. I put 2 clear liquids together and it turns cloudy. Okay? This is the cloudy part, the precipitate. Okay? So that's a reaction. It says if a reaction does occur, now I've got 3 reactions to write. A balanced molecular reaction. That's this one. Done. This is the balanced molecular reaction. See, if the reaction doesn't happen, then you don't go any further. You just put NR for no reaction, and you don't have to worry about balancing or anything. So you may want to balance when you get to the point where you actually know a reaction happened. Just save you some time. It won't hurt to practice the other way. Total ionic. This is new for us. Total ionic. Okay. When we have a solution like this compound dissolved in water, this compound dissolved in water, they don't actually stay together as a compound in the water. They ionize in the solution. So we want to write a picture of what that actually looks like. So what I have is 2 sodium ions, and I have a sulfate ion. and I have a strontium ion. And I have 2 nitrate ions. I don't know why I put parentheses around that, sorry. That's what is actually in the solutions on my reactant side. On my product side, these guys are still just ions. They have not come together to form any kind of compound. So I'm going to represent them still. 2 sodium ions plus 2 nitrate ions. But these two actually do come together, form a compound, and fall out of solution. So they are represented as one combined compound. So that is my total ionic equation. I'm showing all the individual ions and the precipitate that's formed. And in the text, and this, it may even have aqueous for every one of these. I'm kind of blanking out on that, seeming like this is right. And then actually your solid here. Okay. Now, so that's my total ionic. Net ionic and spectator ions. Well, some of these ions, what's a spectator? Somebody watches, they don't actually participate, they're just hanging out, seeing what's going on. Okay? So any part of any ion that doesn't actually participate in forming a compound is just called a spectator. So what is one of those ions that really doesn't do anything from here to here? It looks exactly the same. Sodium is one. And then what is the other one? Nitrate. Okay. So those sodium and nitrate, those are spectators because they don't look any different from here to here. They did not do a thing except hang around and watch what happened. Okay. But, so my net ionic reaction, that's where the action was. Here we had 2 ions originally, and it doesn't matter if you write the sulfate first or the strontium first. I usually just go left to right. And then the product that was formed there, they actually formed the compound, and it's got a sulfur in it, okay? Strontium sulfate. So this is what is called my net ionic. I took out the things that really didn't participate in the reaction. Spectators would have been nitrate and sodium. You got all that? Because I'm going to have to erase it to have room to work with ammonium perchlorate and sodium bromide. Anybody still need this? No. Okay. Then let's look at the second reaction. We have, in B, we have ammonium perchlorate, NH4ClO4. And we have sodium bromide, NaBr. And again, the first thing we do, all of these are positive 1 and negative 1. So that makes for a pretty easy double replacement manipulation. I can just switch partners because all the charges are the same. So I now have my potential products as ammonium bromide and sodium perchlorate. So I go to my rules. There was something about ammonium in one of the rules. I remember that. I think it was number 2. Number 2 says all ammonium salts are soluble. Soluble or precipitate? You're right, that's aqueous. So that's still in solution as ions. Sodium perchlorate, rule number 1. Soluble, right? No reaction happens here. Everything just stays, all these stay in solution, just as ions. So this is one of those. I have a bottle of ammonium perchlorate. I have a bottle of sodium bromide. I put some drops of each one in the two clear liquids together. I look in my little spot plate. I see a clear liquid. No reaction. Nothing happened.
Why do you say potential solutions every time?
Well, because I guess it would be better to say like potential compounds, because they're not actually together. So this reaction doesn't happen. So does ammonium actually form a compound with bromine? No. Does sodium actually hook up with perchlorate and make a compound? No. So these are just like potential matches until we confirm that they precipitate out.
So on the first one was sodium nitrate it didn't react?
It did, and it just stayed as ions in the solution. They didn't come together and make a compound at all.
So it doesn't make sense.
Right. The whatever becomes solid, whatever is insoluble, that actually hooked together and made a compound that came out as a solid. Otherwise, they're just ions hanging out in solution. So that's kind of what's going on here. It's what we will practice. This is pretty much all you'll do tomorrow in class, and you guys can work together and everything, but we'll just do some reactions so you can have practice with writing them, writing the total net ionic, writing compounds, balancing equations, learning solubility rules. So that's what we'll do in class tomorrow. And then on Friday, you actually get to go apply this to real solutions in class. Heck, tomorrow we maybe look at all the combinations you're going to do in Friday's lab, and you can predict which ones you think should form precipitates and see if that actually happens. That would be the best way to go, so I think that's what we'll do. So you've got one to try. You've actually got 4 to try. And we will pick up with those tomorrow, so you can work on them now or take it with you or whatever.
Okay.
And then we'll start with that tomorrow.